Sarah Lindsay in the School of Marine Sciences and the RISE Center, the Maine Center for Research in STEM Education.
And I'm Marina Vanderev. I also work at the RISE Center, and I'm the coordinator for the Maine STEM Partnership. We are here with, I think, about 13 teachers, one joining us remotely, and they are mostly middle and high school teachers who are looking to work more with data in their classrooms, specifically in the context of forestry. So we're learning a little bit about the forestry, we're learning about quantitative reasoning skills, and hopefully by the end of the week we'll start developing some lessons that they can take back to their classrooms to do with their students.
And the other super cool part of this is that we are actually setting up a sensor site for like sunlight and temperature and soil moisture and a lot of things that the scientists are in the same project, this is the Inspires project, are using to characterize the forests of New England. So we're setting up the site with teachers, with the researchers who are going to use the data that are collected on this site. And that's a really cool partnership. It doesn't often happen that the teachers who are going to be designing lessons and curricula around this project actually get to be part of figuring out where in the forest are we going to put this site and getting to put it together so that it can collect data.
Hi, my name is Regina Toulin. I'm a faculty member at the University of Vermont, and my focus is in STEM education. I am one of the personnel on this grant, working with teachers from Vermont, Maine, and New Hampshire to learn about the northern forests. Our goal here today is to have the teachers literally in the field with the scientists, learning about the ecosystem, the trees, and what they're doing today is plotting a site for a sensor that will be installed here in the Schoodic forest, and also a solar panel. So we've got about 14 teachers out here in the field measuring, hammering, digging holes, putting posts in, and getting ready to actually install the sensors and the actual solar panels.
I'm Amy Seidel. I teach biology at Hamden Academy in Hamden, Maine.
My name is Erin Weissel-Mursky, and I teach middle school at U32 in Montpelier, Vermont.
My name is David McNally. I'm a high school science teacher at Winooski High School in Vermont. We're practicing or learning what to install a sensor array that's going to help this Inspires project sample a bunch of forest parameters related to climate factors like snow depth, is that right? Things in the soil moisture, a couple other variables. So we're learning how to install this, and we're actually helping them install this research plot, which will be ongoing.
Well, I think my students will be very excited to know that I've gotten out of the science lab and into a science forest instead. And I think it'll be able to help me bring a little bit of a first-hand experience back to them, because we do a little bit of forestry on our campus and out in some of the woods of Vermont, and just having some hands-on practical experience working with real scientists, collecting real data and learning how this really works, really brings some real-world meat to what I teach my students, and they don't feel like they're just, doing a cookie-cutter lab. They feel like they're really involved in something that's really helping science and the community and the world and their environment.
If you want students engaged, hopefully this will engage students more in science. Part of it is like the nuts and bolts, the drilling, the out there, the troubleshooting, and validating all those skills that people have and need in society. And then whatever we're doing here, we're totally going to have to adapt to schools. We don't live in these beautiful, or teach in these beautiful environments. I don't. I'm in a city. So we're going to have to take lessons from this and somehow adapt them.
Hi, I'm Francie Peterson. I'm a faculty member in the Math Department and the RISE Center, and I work on quantitative reasoning and context. And so I keep looking at all the places where quantitative reasoning is taking place in the Inspires project, especially today with setting up sites. And this group right here, I've been following all day, and we had to figure out where to set up a post for the solar panel. And we determined where it should go, and then encountered some issues on how do we keep it level. And so we've been doing lots of problem shooting, and right now they're working on a whole new solar panel that even the scientists have not installed this way yet. So there's a lot of problem solving and talking to the scientists and thinking about new ideas what to do.
Hi, I'm Peter Goff. I'm from the Vermont Common School in South Burlington, Vermont.
And I'm Andrew Malaby. I'm from Green Mountain Union High School in Chester, Vermont.
I'm Morgan, I'm also from Vermont.
Megan, I teach in Milton, Vermont.
Well, I am looking to hopefully install a very similar system in some land that our school owns to carry out kind of long-term projects that the kids can get involved with for years, and also work with other researchers in other schools.
I think right now we're doing a lot of problem solving and reminding ourselves what it's like to be asked to solve a problem without perfect directions, which is the kind of thing that we make students do all the time. And so while that might not be the exact thing we came here to learn, that's definitely one of those great takeaways.
Quantitative reasoning in context describes more the math and stats used in a specific context to problem solve, to tackle these different forestry projects. Like here we had to figure out where do we put a 30 by 30 meter plot. So you have to figure out what is a 30 by 30 meter plot and where can I actually place it, and then you have to reason about, well, if this plot goes here and if this stake goes here, then only 50 feet away can we place where the batteries have to be. And that needs to be within the plot. So there's all this reasoning happening around the science, and that's what I'm particularly interested in. And if students then can collect data with their teachers, then what do you do with the data? What questions can you ask and how do you answer it? What graphs would help? What evidence can you provide? So that's where the quantitative reasoning aspect comes in.
Step we think that we're on is putting this piece onto the mounting bracket and onto the post, and you'll have to decide which to do first.